Hello chemistry students. In this video I'm going to go over pH and pOH calculations. Alright, so we'll start off here with the pH scale just to give you a general idea. pH of 7 is neutral, that is like pure water, and then things get progressively more acidic as you move down to lower pHs, like all the way down to 1 or 0. Gives you some ideas there, the hydrochloric acid in your stomach, or battery acid, or whatever. And then high pHs, like going up to 13 and 14, your bleach and your drain cleaner and such as that. The stuff that you put in, the oven cleaner that's got sodium hydroxide in it. So, keep in mind that you do need to be aware of pH greater than 7 is a base, pH less than 7 is an acid. Also, the pOH scale reads in reverse to this, so if these values were changed to pOH, 14 would be up here and 0 would be down here for pOH. And that would be really weird, right? Because if a pOH value of 14 would be a strong acid and a pOH value of 0 would be a strong base. So generally speaking, we always use the pH scale in determining whether something is an acid or a base. Alright, so the pH is an indication of the hydronium or the hydrogen ion concentration. That's the H plus in brackets or H3O plus in brackets. So there you go, there's the H3O plus. Could replace that with H plus just as easily. So the way you calculate pH is you take the negative log, that is a base 10 log on your calculator. If you just enter in the log, or you take the log, it'll do the right thing. You don't have to specify the base, just don't use the natural log key. Alright, of the hydrogen ion concentration, that's what how the brackets read. So if you see brackets around some compound, that's indicating the concentration in molarity of that compound. So we would take the negative log of that to get the pH. Alright, so we already kind of talked about figured out whether something's acid, base, or neutral, and we're always going to use pH to determine that. Alright, so here's an example. What is the pH of 1 times 10 to the minus 8th molar hydrogen ions? And so our unknown there is the pH. The known is the hydrogen ion concentration or the hydronium concentration. So we would use the pH equation for that and plug in a numerical value, and we should get 8 when we do that calculation. If you haven't already, give it a try and make sure you can get the same thing on whatever calculating device you're using. Some cell phone calculators, if you turn the cell phone sideways, then it'll give you more options or buttons or whatever there. That's how mine works anyways. Okay, here's another example. We're going to calculate the pH of a solution with a hydronium ion concentration of 5.0 times 10 to the minus 6 molar. So we want to know the pH, we know the hydrogen ion concentration, and we'll use the pH equation and plug in the value that we have, and you should get a pH of 5.3. Right, so pOH is based on the hydroxide ion concentration, and that is the negative log of the hydroxide ion concentration. So let's practice with that. Alright, so what's the pOH of some 1 times 10 to the minus 11th molar hydroxide? And so the unknown is the pOH. We know the hydroxide concentration. The pOH equals negative log of hydroxide concentration. And we'll plug in the concentration of the hydroxide, and then we get 11. Alright, in another example, we're going to calculate the pOH of a solution with a hydroxide ion concentration of 3 times 10 to the minus 6 molar. Right, so the unknown is the pOH. We know the hydroxide ion concentration, so we use the pOH equation. Plug in our values, or really just our one value, and we should get a pOH of 5.5. Alright, so let's talk about how you get hydrogen ions and hydroxide ions from water. So water can self-ionize or auto-ionize, and basically what happens is occasionally, very rarely, about one out of every 10 million water molecules, this would happen to in pure water. So the hydrogen from one water molecule gets transferred to another, and that makes a hydronium ion and a hydroxide ion. And as long as the hydronium and the hydroxide are present in equal amounts, the water is still neutral, because this is the particle that makes it acidic, and this is the particle that makes it basic. And if they're in equal quantities, then the solution is neutral. Alright, so neutral is the case where the OH minus equals to H3O plus, or you could just do H plus there. Alright, and that concentration for water at, I believe it's room temperature or somewhere thereabouts, is 1 times 10 to the minus 7th molar. Okay, the hydroxide and the hydronium ions are inversely related to each other. And what that means is that when one goes up, the other goes down. This is related by a mathematical expression that says that the hydroxide ion concentration times the hydronium concentration equals a constant. And that constant is Kw, and it's valid at about room temperature, about 25 degrees Celsius. So, what we can take away from this mathematical expression is what we said earlier, that these are inversely related. So if the OH goes up, then the H3O plus will go down, and vice versa. Alright, so just to kind of take a thought of what would occur as different things are put into solution. So hydrochloric acid, when it goes into solution with water, that it would make hydrogen ions, and there would be more hydrogen ions than hydroxide ions, which would make it be an acidic solution. Alright, so if you have more hydrogen ions than hydroxide ions, it's an acid. Vice versa, it's basic. Here's an example of that. So if some sodium hydroxide dissolves in water, it would result in there being additional hydroxide ions added. And then in the case where hydrogen ions or hydronium are equal to hydroxide ions, then you have a neutral solution. Alright, so let's do a little bit of practice with this. So we're going to calculate the hydroxide ion concentration if the hydronium is 3 times 10 to the minus 1 molar. So we're known as the hydroxide ion, known as the hydronium. So this time we have the hydroxide and hydronium, so we're going to use the Kw equation. Plug in the value for Kw, plug in the value that we were given for the hydronium concentration, solve for OH by dividing by 3.0 times 10 to the minus 1. And you should get 3.3 times 10 to the minus 14th molar when you carry that calculation out. Alright, this time we're going to calculate hydronium ion concentration. Give it a try, pause the video, and then come back and look at the solution. Alright, so basically the reverse of last time, still the same equation. This time we'll plug in the hydroxide ion concentration to solve for hydronium. Divide both sides by 2.0 times 10 to the minus 3rd, and you should get 5 times 10 to the minus 12th. Alright, going between pH and pOH is pretty much the easiest calculation you can do in this particular unit. So the relationship between pH and pOH is simply that pH plus pOH equals 14. So, for example, if you are going to find the pOH of a solution, if you're given a pH of 8, then you just subtract 8 from 14, and that would give you the pOH. If you're asked to solve for the pH of a solution given the pOH of 10, well, same process, subtract the pOH from the 14, and you would get a pH of 4. Alright, so here's a summary of all the equations to relate pH, pOH, hydrogen ion concentration or hydronium concentration, and hydroxide ion concentration. These are found on page 3 of your reference table, and here's a map that relates all of these quantities to one another. So if you need to go from pH to H+, then you use this equation. If you need to go from H+ to pH, then you use this equation. pOH to, from OH minus hydroxide ion concentration to pOH, use this equation. From pOH to hydroxide ion concentration, use this equation. And if you're moving between pH and pOH, then pH plus pOH equals 14. Solve for the one you don't know. And if you're moving back and forth between H plus and OH minus concentrations, then you would use the KW equation down here at the bottom. And we demonstrated earlier how you plug in the one you know and solve for the one that you don't know. So this helps you organize and also realize how many steps it'll take you to get from one point to another. Like, let's say we had hydrogen ion concentration and we wanted to solve for pH, then it would be 2 steps for us to get from hydrogen ion concentration to pOH. Alright, so we're going to determine the pH and pOH of a solution which contains 0.035 mole of hydronium per liter, and then is this an acid, base, or neutral solution? So our plan here is that we need to first find the pH from the H3O+, and then we're going to use pH plus pOH equals 14 to get to the pOH. Alright. So step 1 here, we'll find the pH, take the negative log of the hydrogen ion concentration, and then we'll subtract from 14 to get the pOH. And that would be an acid because it has a pH less than 7. Alright. What is the pOH of a solution containing 0.042 molar KOH? Is it an acid, base, or neutral? It's probably going to be a base because potassium hydroxide is a base, but we'll find out in a moment. So first off, let's talk about what happens when the KOH dissolves. So it's a strong base, so all of it ionizes. So that means the KOH will dissolve, and if we, for each KOH there's one hydroxide, so if we start with 4.2 times 10 to the minus 2 molar potassium hydroxide, then after it all dissolves there will be none of that, and then stoichiometry tells us that we'll get the same concentration of hydroxide. So that's what we'll plug in to our calculation. So our hydroxide ion concentration is the same as the KOH, and we'll plug that in to the pOH equation, and we should get a pOH of 1.38. To figure out if it's a base, we'll convert that to pH that by subtracting from 14, and that gives us a value greater than 7, so it is a base. Alright, this time we're going to do a similar process except for barium hydroxide. Notice the 2 here. When this dissolves, each barium hydroxide makes 1 barium ion and 2 hydroxide ions, because those hydroxide ions do not stay together with one another when it dissolves. So that means if you start with this concentration of barium hydroxide, it all dissolves, and the concentration of the hydroxide ion is double that. So that is what we'll plug in when we do our calculation, and you get a pH or pOH of 1.15. Convert that to pH so you can tell if it's acidic or basic. It's greater than 7, so it's basic. Alright, and here is an example where you find the hydronium ion concentration when you know the pH. So this is the equation you use, and thanks for watching.